So this will be the end of section 1.3. There really isn't anything new in this part. There's just a handful of problems to do. Unfortunately, they're really long. The instructions for each of the problems between 19 and 34 say determine which of these are true. Choose every answer that's true. In many instances, there'll be more than one correct answer. And what we're going to be given in every problem between 19 and 34 is a set called A and a set called B. And we're supposed to check to see which of these statements, whether A is equal to B, A is a subset of B, B is a subset of A is a proper subset of B, or B is a proper subset of A. We need to check to see which, if any, of these are true. And if none of them are true, we're going to say none of these are true. So I'm just going to jump into number 20 and show you what I mean about how to do these problems, and you might be able to go through all the problems without me holding your hand, because there isn't anything new. It's just a matter of doing a lot of tests at once. So the first thing I'm supposed to check is if these two sets that were given to me are equal. And for two sets to be equal, they have to have exactly the same elements. These sets aren't equal because A has white in it that B doesn't have. This A equal to B is not going to be included in my answer. I don't need to say why this isn't true. I just need to say that it's not true. Or I don't even need to say that. I just don't need to include it in my answer. The next item I was asked to check to see is if A is a subset of B. And for A to be a subset of B, I have to do two tests. The first test is A has to be a set. Because A is in set braces, it's a set. The second test I need to do is where it's going to mess up. The second test for A to be a subset of B is every element in A has to be in B. This white that kept the sets from being equal is also keeping A from being a subset of B. For A to be a subset of B, red, white, and blue would have to be in B, which they're not. So this rule was not satisfied. So this symbol is not going to be part of my answer because A is not a subset of B. The next symbol that I'm asked to test is B is a subset of A. For B to be a subset of A, two criteria need to be satisfied. B needs to be a set, and every element of B needs to be an element of A. I look at B, it's in set braces, so it's a set. That's good enough. Now I move on to test 2, see if every element in B is in A. There are two elements in B. Red is in B. For B to be a subset of A, it also has to be an A, which it is. And blue is an element of B. For B to be a subset of A, blue also has to be an A. Every element of B, red and blue, is also an element of A. So rule 2 is satisfied. And this needs to be part of my answer. So when I go to answer number 20, the first symbol I'm going to include in my answer, I'm not going to include the A equals to B. I'm not going to include A as a subset of B. But I will include B as a subset of A in my answer. I'm going to move on next and see if A could be a proper subset of B. For A to be a proper subset of B, there's three criteria that need to be satisfied. If any one of the three criteria is violated, then this is not going to be part of my answer. So for A to be a proper subset of B, A needs to be a set, and it is a set because of the set braces. Second criteria, every element of A has to be an element of B, and this is the one that's violated because there's an element in A that's not also in B, so this is violated. And soon as one of the three rules for a proper subset is violated, then you can stop and that won't be part of my answer. One last symbol to check. Let's see if B is a proper subset of A. To see if B is a proper subset of A, I've got to do the three rules. The first of the three rules is B needs to be a set. Because of the set braces, B is a set, so that rule is satisfied. Second rule for B to be a proper subset of A is every element of B needs to be an element of A, and we know that that's true because the two elements in B, red and blue, are also in A. So the second rule of being a proper subset is also satisfied. Proper subset has the third criteria that the sets can't be equal, and these sets aren't equal because A has white that B doesn't have, so they're not equal. So all three criteria, B is a set, the two elements of B are contained in A, and B doesn't equal to A. So this needs to be part of my answer. And that's the last thing that I needed to check for. So I'm going to finish up my answer for question 20. My answer is going to be B is a subset of A, and B is a proper subset of A. When you go to do your problem 19, the answer to 19 is exactly the same. B is a subset of A, and B is a proper subset of A. I'm going to go through these kind of fast because I think you don't need my help so much. As a matter of fact, let me show the answer to 21 up here just in case you want to do it and fast forward through me doing problem 22. The answer to 21, the three symbols that are true, are A is equal to B, A is a subset of B, and B is a subset of A. I'll do 22 for you just in case you need to see something that basically solves just like 21. So for 22, the sets are given, and the first thing I need to see is if they're equal. And two sets are equal if they have exactly the same elements. A has the three elements A, B, and C. B, even though it's written in the same order, has the three elements A, B, and C. Because they have exactly the same elements, that's all it takes to be equal. And part of my answer to 22 is going to be A is equal to B. The next thing I'm going to check to see is if A is a subset of B. For A to be a subset of B, there's only two rules. The first rule for A to be a subset of B is A needs to be a set. It's in set braces, so it's a set. The second rule is every element in A needs to be in B. Well, let me see. A is in A. It's also in B, so we're good there. The second element of A, B, is also in B, so we're good there. And the last element in A, C, is also in set B, so we're good there. The three elements in A are also in set B, so it satisfies that rule. This symbol allows the sets to be equal. Because both rules here have been satisfied, I'm going to say that's going to be part of my answer as well. So the second symbol I'm going to put in my answer is A is a subset of B. Third thing I'm going to check to see is if B is a subset of A. For B to be a subset of A, I need two criteria. B needs to be a set. It's in set braces, so it's a set. Second, every element in B has to be an element of A. There's three elements in B. C is in B. It's also in A. B is in B. It's also in A. A is in B. It's also in A. The three elements of B are also in A, so every element of B is also an element of A. So that is good, and this symbol needs to be part of my answer as well. So the next symbol, and probably the last symbol I'm going to put in my answer, is B is a subset of A. Moving on to checking for A as a proper subset of B. For A to be a proper subset of B, I have to check three rules. And I've already checked the top couple rules when I was doing regular subsets. This is the rule right here that's going to keep this from not being part of my answer. Because for A to be a proper subset of B, the sets can't be equal, but these sets are equal. So I'm going to just say this one's not going to be part of my answer. I'm not even going to worry about 1 and 2 because I knew that these sets were equal. And for proper subsets, I'm not allowed to have equal sets, so I'm not going to include that in my answer. Last thing that I need to check before I call myself done with this problem is to see if B is a proper subset of A. For B to be a proper subset of A, there's three rules, and the last rule says that those sets can't be equal, but these sets are equal, so the third rule is going to be violated, and that's not going to be part of my answer. So the only things that go in my answer for problem 22 are the A is equal to B, the A is a subset of B, and B is a subset of A. It's exactly the answer you're going to get for problems 21. Just in case you want to do 23 without me, without watching me do any more, the answers to 23 is going to be A is a subset of B and A is a proper subset of B. I'll do my problem 24 just in case you need to see it. So the first thing I'm going to check for in problem 24 is if the two sets are equal, and these sets clearly aren't equal. To be equal, you have to have exactly the same elements, and A has two elements in it that aren't in B, so these sets aren't equal. I won't include it in my answer. Now I'm going to see if A is a subset of B by doing the two-rule check for being a subset. The first rule is A has to be a set. Because it's in set braces, it's a set. The second rule are the 4 elements in A also have to be elements in B, and this is not good because these two elements, 2 and 5, are in A, but they're not in B, so that rule gets violated. The A as a subset of B is not going to be part of my answer to problem 24. Next symbol I'm going to check to see if B is a subset of A. For B to be a subset of A, I need to check 2 rules. First rule, B needs to be a set. Because it's in set braces, it's a set. The second rule, the 2 elements in B have to be elements of A. Well, 7 is in B, it's in A. 9 is in B, it's in A. Every element, or the 2 elements in B, are also in A. So rule 2 has been satisfied. There isn't a rule 3 I need to worry about. This symbol needs to be in my answer because both the rules have been satisfied. So part of my answer to 24 is going to be B as a subset of A. Now when I look for proper subsets, first I'm going to check to see if A is a proper subset of B. For A to be a proper subset of B, there's 3 rules. A needs to be a set. It's in set braces, so that rule's satisfied. The second rule, all 4 elements in A also have to be elements in B. This is the rule that's violated because there's 2 elements in A that aren't in B. This rule is violated. I'm not going to put that symbol in my answer. The last symbol I need to check is to see if B is a proper subset of A. So I'll go through the 3 rules for B to be a proper subset of A. The first rule, B needs to be a set. It's in set braces, so it's a set. Second rule, the 2 elements in B, 7 and 9, also have to be in A, which they are, so it satisfies the second rule. And the third rule for proper subset is the 2 sets can't be equal. These aren't equal because they don't have the same elements or the same number of elements, so that rule's satisfied. I also need to include B as a proper subset of A in my answer. So to finish up my answer to question 24, I'm going to add the symbol B as a proper subset of A. And again, just in case for your 23, you're supposed to do A is a subset of B, and A is a proper subset of B for your 23. For 25 and 26, ours are different. Are they? No, they're not. They're going to be similar. Let me walk. Well, I'll do 26. Your 25 is going to be none of these. I probably could have said none of these for my answer, but I just wrote none. It's going to turn out we're going to check every one of these, and everyone's going to be a no. And this is when we're going to write none of these for our answer. So I'm going to do 26, which is an example of a none of these, just to show you how a none of these can come up. First symbol I need to check is if A is equal to B. They're clearly not equal. A has the letter E in it that B doesn't. It has a letter G in it that E doesn't, but B doesn't. They have to be have exactly the same elements, and they don't have exactly the same elements. They don't even have the same number of elements, so that one's no good. Next check, I need to see if A is a subset of B. There's 2 rules. A needs to be a set. No problem there because it's in set braces. The second rule, all 4 elements in A need to also be elements in B. And this is the rule that breaks up because those 3 elements that are in set A aren't in set B. So that rule gets violated. So I can't put A as a subset of B in my answer. Next, I want to check to see if B is a subset of A. For B to be a subset of A, there's 2 rules. First one is B needs to be a set, which it is. Second one, all 3 elements in B also have to be in A. And these 2 elements in B aren't also in A. So the second rule gets violated, and B is a subset of A. It's not going to be in my answer. 2 more to do, the proper subsets ones. Now I'm going to see if A is a proper subset of B. For A to be a proper subset of B, there's 3 rules to check. First, A needs to be a set. It's in set braces, so that's good. Second rule, all 4 elements in set A also have to be elements in set B, and this is where this is going to break down because there are 3 elements in set A that I don't see anywhere in set B, so that rule gets violated, and I'm not going to include that in my answer. Last symbol to worry about is B a proper subset of A. For B to be a proper subset of A, I have to check 3 rules. The first rule, B needs to be a set. B is a set because it's in set braces. Second rule, all three elements in set B need to be elements in set A. But there are two elements in set B that aren't elements in set A, so that rule's violated. Once I violate a rule, that symbol can't be in my answer. Unfortunately, I went through every single possibility. I checked every one of these symbols and I got an answer of no for each one of those. And then when that happens, we write none of these for our answer. And that's exactly what your answer for 25 is going to be. 27 and 28 want us to take a set from set builder notation and write it in roster form before we start answering the questions. So in 28, my set contains all the natural numbers that are less than but not equal to 5. My set A is going to contain the numbers 1, 2, 3, and 4. So before I go on to check each one of these, I need to get A written in roster form. Your set A in problem 27 is going to have the numbers 1 through 8. It's not going to have 9. It's only going to have natural numbers up to but not including 9. So when you go to do your problem 27, you have to think of A like that. The answer to problem 27 is going to be B as a subset of A and B as a proper subset of A. Let me just see which ones for 28 work. So the first thing I'm going to do is check to see if the sets are equal. If I look at the sets, they're not equal because A has the number 4 that B doesn't, so that's not going to be part of my answer. The next thing I'm going to check is to see if A is a subset of B. For A to be a subset of B, every element, A needs to be a set, which it is, and every element in A needs to be in B, which it isn't, because there's an element in A, the number 4, that's not in set B, so I'm not going to include that symbol in my answer. Next symbol I'm going to check to see if B is a subset of A. For B to be a subset of A, there's just two rules that need to be satisfied. The first rule, B has to be a set, because B's in set builder notation, it's a set. The second rule, each of the three elements in B have to be elements in A, and the three elements in B are also elements in A, so the second rule is satisfied, and B as a subset of A is going to go into part of my answer for number 28. Two more things to check. Next, I want to check to see if A is a proper subset of B, and again, I need to write down A with the roster form, otherwise I'm going to mess up. So for A to be a proper subset of B, there's three rules. First rule, A needs to be a set. It was a set in set builder notation. It's a set in roster form. Second rule, each of the four elements of A have to be in B, and this is where I break down, because there's an element of A that's not in B. So this is not going to be part of my answer, because it violated the second rule to be a proper subset. Last one I need to check. And again, I'm rewriting A down in its roster form. So for B to be a proper subset of A, there's three rules that need to be satisfied. The first rule is B needs to be a set. It's in set braces, so it's a set. Second rule, all three elements in B, 1, 2, and 3, also have to be in set A, which they are, so I'll put a big check there. Last rule for proper subset is the sets can't be equal. They're not equal because the A has that 4 in it. So all three rules of being a proper subset are satisfied. So I'm going to put a big yes for that, and I'm going to include B as a proper subset of A in my answer. Again, your answer for 27 is exactly the same answer as mine. B is a subset and B is a proper subset of A. 29 and 30. Start getting very tedious. Just in case you just want to move on from 29, the answer for your 29 has the A's. It's A as a subset of B and A as a proper subset of B. I think that will be the end of this part of the video, and you can move on to the second part. Or I'm sorry, it's not going to be the end of this. So my video's got a hiccup, and I'm going to have to make a second part, but you won't even notice it. There'll be two more problems to do after this. So for problem 30, I'm going to rewrite A in roster form. And my set A has any natural number that's 5 or bigger. It's an infinite set. A is going to have, starting with 5 and going on to infinity, every natural number. Your set B for problem 29 is going to have the numbers 9, 10, 11, 12, and going on to infinity. So let me check to see if these sets are equal. Well, A starts at 5 and goes to infinity. B starts at 4 and goes to infinity. These aren't equal because B has a 4 that A doesn't have, so that's not going to be part of my answer. The next thing I need to do is see if A is a subset of B, meaning every element of A is a set, and every element in A is also a B. A is a set because it's written in set builder notation. Every element of A, 5, 6, 7, and bigger, are also in B, because that dot 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 includes, that 8. So this is satisfied, and A is a subset of B is going to be included in my answer. So part of my answer to number 30 is A is a subset of B. The next symbol I'm going to work on in problem 30 is the B is a subset of A. For B to be a subset of A, B needs to be a set. It's in set builder notation, so it's a set. Also, the second rule, every element of B needs to be in A, and this is where it breaks down because there's a 4 in B that's not in A. So the second rule gets violated and that symbol won't be in my answer. Second to last rule, A is a proper subset of B. For A to be a proper subset of B, I need to satisfy 3 rules. A needs to be a set. It's in set builder notation, so it's a set. If I write it in roster form, I write it like that. The second rule to be a proper subset is every element of A needs to be in B, and every element of A, 5 and bigger, natural numbers, are in B, so that rule is satisfied. And the third rule for A to be a proper subset of B is they can't be equal, and they're not equal because A doesn't have a 4 that B does have, so this is satisfied, and I'm going to include that symbol in my answer. So far I have A as a subset and A is a proper subset of B. One more test to do to see if B is a proper subset of A. For B to be a proper subset of A, B needs to be a set, which it is. Unfortunately, it's going to violate the second rule. To be a proper subset, every element of B needs to be an element of A. A starts at 5. It doesn't have a 4 in it that B has, so the second rule is violated. This symbol is not going to go in my answer, so I'm not going to add any more. I've checked all the symbols, and there's nothing more to put in my answer, so I'm going to stop there and call that my answer for problem 30. So we just have 2 more problems to do, and I need to pause my video because at 24 minutes it breaks and I've got to piece the videos together, so there might be a little hiccup here. So we just have 2 more to go. Let me write the answers down to 31 for you. For 31, I get A equals B, A is a subset of B, and B is a subset of A. And let me also try to flash up 33, just in case you just want to not watch the video and just finish these problems. For 33, I get A is a subset of B, and A is a proper subset of B. So if you just want to try those without watching me do the problems that are similar, I don't have a problem with that at all. So I'll go through and do 32 right now and see where that takes me. So for 32, I'm given sets A and B. A are the natural numbers in between 0 and 5, not including the 0 and 5 because I don't have the or equal to. So A, for me, is just going to have the numbers 1, 2, 3, and 4. In your set 31, your A are going to have natural numbers between 2 and 9, not including the 2 and 9. So your set's going to have 3, 4, 5, 6, 7, and 8. Well, now let me just go through it and do my tests for 32. So A turns out to be equal to the set containing 1, 2, 3, and 4. First thing I'm checking to see if they're equal. These are clearly equal. So I'm going to put a big old yes there. I'm going to include that in my answer to 32. For A to be a subset of B, where A is a set containing the numbers 1, 2, 3, and 4, and B is a set containing 1, 2, 3, and 4, I have two checks. A needs to be a set, was in set builder notation, so it's a set. And then every element in A needs to be in B. There are 4 elements in A. Those 4 elements are also in B. I satisfy that rule. I don't have the third rule that they can't be equal, so I've satisfied the 2 rules, and that's another big old yes. So part of my answer, part of my answer is not yes. Part of my answer so far is going to be A equal to B, and A is a subset of B. Next, I'm going to try to see if B is a subset of A, where again, A is a set containing the natural numbers 1, 2, 3, and 4. For B to be a subset of A, B needs to be a set. It's clearly a set. It's in set braces. Second, every element in B is also an element of A. The elements of B, 1, 2, 3, and 4, are also elements of A. Both of these criteria are satisfied, so B as a subset of A is going to be in my answer for problem 32. Now I'll move on to the proper subsets. Is A a proper subset of B, where A is a set containing 1, 2, 3, and 4, and B is a set containing 1, 2, 3, and 4? And I'll just go right to the punchline. The answer to this is no, because for a proper subset, you need to satisfy 3 rules. The third rule says the sets can't be equal, but these sets are equal, so this is not going to be in my answer to problem 32. Similarly, the last symbol that I'm asked to check to see if B is a proper subset of A, I have 3 rules that need to be satisfied, and because these sets are equal, the third rule is being violated, and that symbol shouldn't belong in my answer. So the only symbols that belonged in my answer for problem 32 were A equal to B, A is a subset of B, and B is a subset of A, turns out to be exactly the same answer to your 31. So just one more problem each. For my problem 34, I need to get out of that set builder notation. And for set A is the natural numbers between 0 and 5, not including the 0 and 5. So my set A is the set 1, 2, 3, and 4. My set B is the 0, 1, 2, 3, and 4. So let me check to see which ones work and which ones don't work. For my set A and my set B. The first one asks if the sets are equal. They're not equal because B has a 0 and A doesn't have a 0. So I'm just going to put a big no there. Second one, A is a subset of B. Well, let me see. A has to be a set, which is good. Satisfies the first criteria. Second criteria, every element in A, 1, 2, 3, and 4, have to be in B. Since every element in A is also in B, I satisfy the second criteria. I put a big yes to this symbol, and when I go to write my answer, I write A is a subset of B in my answer. Next symbol is B a subset of A. Well, I need 2 rules for this to be true. First, for B to be a subset of A, B needs to be a set. B is in set braces, so B is a set. Second, for B to be a subset of A, every element in B needs to be in A, and this is where I break down here, because the number 0 is in B, and it's not in A when we list it in roster form. So I'm going to put a no for this. Now I'm going to check to see if A is a proper subset of B by comparing the roster form of A, set 1, 2, 3, and 4, with the roster form of B. For A to be a proper subset of B, there's 3 criteria. First criteria, A has to be a set. Was given in set builder notation, so it's a set. Second criteria, every element in A is an element in B. That rule is satisfied. Last, the sets aren't equal. The sets aren't equal because B has a 0 that A doesn't have. That rule is satisfied, so I'm going to put a big yes for this. And that symbol, A is a proper subset of B, is also going to go in my answer to 34. Very last one for this video, to see if B is a proper subset of A. For B to be a proper subset of A, B needs to be a set. It's a set. Second criteria, every element in B needs to be in A, and this is where I break down because 0 is in B, but 0 is not in A. So that second rule breaks down. Once one of the rules breaks down, I have to answer no for that symbol. Done with checking all the symbols. The only symbols that were true were these two with the A's to the left of the B. All right, so that's everything that we need for this section. So hopefully it makes a bit of sense and you do well with it on the test.